Hello everyone. Good morning to all of you guys. How are you all? Is my voice clearly audible to you all? Can you please respond in the chat box? YouTube guys, can you please respond in the chat box whether my voice is clearly audible or not? Yes. Whether my voice is clearly audible to you all and also my screen is visible clearly to you all. Everything is okay to start the class? Okay. It's time to start your class. Let's start. So in the previous class, we have covered greatest integer function and also fractional part function, and also we have seen how to find the domain and codomain, domain and range of a function, and how we can verify whether two functions are equal or not, right? All these things we have covered in the last class. In today's class, we'll see some problems on domain and range of a function. Okay, let's start solving some few questions. Okay, so just revise the concepts. What is domain of a function? The function domain. Sure. So domain of a function is if f is a function which is mapping from A to B, right? So A is the domain of the function and B is the codomain of the functions, right? Okay, A is the domain and B is the codomain, and all set of all mapped elements in the set B, or we can say the set of all outputs, or we can say the set of all values of y after putting the values of x what you are getting, that is the set of range, right? And I already told you in the last class, range is always subset of codomain, right? Okay. Chalo. So here some domain and range of standard functions are given on your screen. You can take a screenshot of all these domain and range of all the standard functions. Already you have studied all these things, है ना? Identity function, domain of identity function is set of real numbers, and also range is R. Constant function की R होता है domain, and range is also R. Set of all real numbers. Polynomial functions, set of all real numbers, and the range depends upon the degree of the polynomial. Okay. And degree, why degree? Because if it is positive, sorry, it is even degree, then it will be giving you only positive values, right? So like we can say here, y is equal to x square. So it is giving you always non-negative values, right? Starting from 0 to infinity. Exponential function a raised to x, which domain is R. You have to remember all these domain and range of all these standard functions, right? So exponential function, domain is R, range is 0 to infinity, where 0 is excluded and 0 is excluded, right? And logarithmic function, in case of logarithmic function, domain is 0 to infinity, where 0 is excluded and range is R. All of you know all these things, na? Already Trivendu sir have discussed all these domain and range of the functions with you all. Okay. So next, modulus function. In modulus function, domain is R, range is 0 to infinity, where 0 is included, infinity. Okay. Signum function, range is -1, 0. The set contains the elements -1, 0, 1. Signum function R, right? Signum function, domain is R, and yeah, domain is R and the range is -1, set contains the elements -1 0 1, sorry, modulus function range is 0 to infinity, right? Greatest integer function, already we have discussed these two functions in the last class. Domain of greatest integer function is R, and range is the set of all integers. Fractional part function, the domain is R of fractional part function, and range is 0 to 1, where 0 is included and 1 is excluded. You have to remember all these domain and range of all these standard functions, because they will be very much useful in future or in calculus also, right? So let's move to some other functions. Like here already you have covered trigonometry in class 11th, right? I hope all of you know what are the domain and range of trigonometric functions. Okay, so how many trigonometric functions we have? 6. One is sine, cosine, tangent, cosine, cosecant, secant, and last one is cotangent, right? So domain of sine is R, all of you know. Domain of sine is R, range is -1 to 1 closed interval. Cosine is R, domain is R. In case of cosine, domain is R and range is -1 to 1 closed interval. Tangent, tan, when the function is tangent, the domain is R minus the odd multiple of pi by 2. Odd multiple of pi by 2. Why? Why we are excluding these numbers from our set of real numbers? Because at all these points tangent is not defined. Pi by 2 simple, 3 pi by 2, at all this odd multiple of pi by 2 tangent is not defined. That's why we are what we are doing, we are excluding all these points from the set of all real numbers, excluding except all these numbers. On all real numbers tangent is defined, right? And range is R, because the graph, you can imagine the graph of tangent function. The graph of tangent function, the graph goes from -infinity to infinity on y-axis. That's why the range is R, right? And cosecant का जो डोमेन है ना, डोमेन इज R माइनस n पाई, R माइनस n पाई, ठीक है? Integral multiple of pi, integral multiple of pi. We have to, from the domain of cosecant, we have to exclude the integral multiple of pi from the set of all real numbers, right? And the range is R minus closed interval of -1 to 1, right? ठीक है? So these are the similarly secant का जो domain होता है, that is R minus or multiple of pi by 2, and range is same as cosecant. I hope all these things are you have covered in class 11, because already you have completed trigonometry, right? Chalo. Cotangent similarly, the domain of cotangent is R minus integral multiple of pi, and range is R. I hope all of you know the graph of all the graph of trigonometric functions, right? Because after this class only we will be starting the composite function and inverse function. So when we'll use inverse functions, there also we'll use inverse trigonometric functions, and that time also we have to use all these domain, codomain and range, right? Okay, let's see that we'll discuss in the next class. So let's move. So here some rules, I'm telling you some rules. You have to remember all these rules to find the domain and range of a domain of a function, right? Suppose f of x is a function which is mapping from A to C, and g of x is another function which is mapping from B to D. A is the domain of f of x and C is the codomain. B is the domain of g of x and D is the codomain, right? So domain of f of x is A, domain of g of x is B. So how we can find, if I'll ask you to find the domain of f of x plus g of x, that will be the intersection portion of A and B. What is A? A is domain of f and B is domain of g. Very good morning, JNB. Bhavnagar. What is its name? Yeah, Bhavnagar. Bhavnagar. Okay. So domain of, similarly, if I'll ask you to find the domain of f of x minus g of x, so that will be a intersection B, same as f of x plus g of x, right? So when you have in addition, subtraction, and product of two functions, and both the domain of both the functions are given, or you have domain of both the functions, then the domain of sum of functions, subtraction of the difference of the functions, and product of that those two functions will be A intersection B. Remember, A intersection B. And finally, in case of division, domain of f of x upon g of x is A intersection B, A intersection B, but from the set B, we need to exclude the points where g of x or where the denominator becomes 0. Because if the denominator becomes 0, then the function will not be defined. Let's see some example to understand all these rules, right? Let's see. Sorry. Yeah. For a few more rules for you also here. If the function is in this form, y is equal to 1 by f of x, then the domain, how we can find the domain of this function? Just equate this equation, that is f of x is not equal to 0, because f of x is not equal to 0, function will be not defined. Similarly, y is equal to under root of some function. Y is equal to under root of some function. So to define this function, or this function to be defined, f of x must be greater than equal to 0. कुछ भी हो अंडर रूट में, तो वो फंक्शन अंडर रूट वाला फंक्शन को डिफाइन होने के लिए अंडर रूट के अंदर में जो फंक्शन है या कुछ भी है, दैट कुछ भी मस्ट बी ग्रेटर देन इक्वल टू 0. क्लियर एवरीवन? So by solving this inequality, what is the solution you will get? What is the solution set you will get? That will represent to the domain of the given function. Similarly, y is equal to 1 if the function is in the form of y is equal to 1 upon under root of f of x. So here only this function to be defined, f of x must be greater than 0. But why we are not taking equal to 0? Because under root of f of x is present in the denominator of the given function, right? So if it is present in the denominator, if you take the equality condition, equality case, then f of x becomes 0, then denominator becomes 0. So if denominator becomes 0, then the function will not be defined. That's why in this case, we'll take this inequality, that is f of x is greater than 0. Clear everyone? Okay. Fourth case, if it is it is in the form of y is equal to cube root of f of x, then f of x belongs to R. F of x belongs to R, right? You will find the domain if some special type of function is given on root, then it's depend upon the case. Okay. So fifth case, y is equal to log of f of x by g of x. Already sir have discussed the logarithmic functions. So how the logarithmic function will be defined? So logarithm function to be defined, all of you know, I hope. So log of f of x to the base g of x to be defined, argument must be greater than 0. Argument means f of x must be greater than 0, right? And this base must be greater than 0, base to be defined, or this log f of x to the base g of x is to be defined. Argument of the logarithm function must be greater than 0, that is f of x is greater than 0, and g of x is greater than 0, and g of x is not equal to 1, right? So by solving these three inequality, what is the solutions you will get? That will represent to the domain of the given function. Okay. So last one, y is equal to a to the power f of x. In this case, the domain f of x belongs to R. And the power of a, exponent of a, if exponent is a function f of x, then f of x belongs to R, right? Okay, now on your screen, some small questions are given. Just take 2 minutes to solve these 3 questions and write your answers in the chat box quickly. And your time starts now. Very small examples are questions are given on your screen. Just take 1 or 1.5 minutes. It will be solved. When you are getting the answer, please write your answer in the chat box. Yes. Very good. Zenvi Nelor is saying that the first one, R minus 3 is the domain. Very good. For the second one and third one. For the second one, the domain is R minus 4. Think about it. When you are answering the question, when you are solving the questions, just observe the question clearly. अच्छे से देखो क्वेश्चन क्या दिया है, x minus 2 into x minus 2 upon x minus 4. In the last question, x square by x minus 1 into x. Okay, so it's time to discuss the solution with you. Let's see what are the solutions. Yes, f of x is equal to 1 by x minus 3. So this function to be defined, already I have told you 1 upon f of x, if the function is in the form of 1 upon f of x, right? So then f of x is not equal to 0. This function to be defined, f of x is not equal to 0. That means in place of f of x, we are having here x minus 3. Very good, Jane B. Nelor. All the answers you have given, all are correct. Third questions you didn't answer. And domain will be x is not equal to 3, that is R minus 3, except the number 3, always the function f of x is defined for all real values of x except 3, right? Come to the second function, f of x is equal to x minus 2 upon x minus 4. So here the function is given as x minus 2 upon x minus 4. Then the domain will be x minus 4 is not equal to 0, this function to be defined, because in the denominator x minus 4 is present. If x becomes 4, then the denominator becomes 0. Then the function will not be defined, right? Then the domain here, in this case, the domain will be R minus 4, right? So 4 is not included. Okay. The set of all real values of x except 4 is the domain of f of x. You can think about it also in this way. F of x is equal to x minus 2 upon, sir, we can x minus 4. Yes, it's oh, I thought it is x square. Sorry. Good, clear. Okay, so domain is R minus 4. If it is given in this format, I thought it is x square, right? Okay, forget about it. So in the last question, option C, f of x is given as x square upon x minus 1 into x, right? So this function to be defined, all these functions are in the form of 1 upon f of x. So x into x minus 1 is not equal to 0. So when x into x minus 1 is not equal to 0, either x is not equal to 0 and x is not equal to 1. Okay. So domain of this function will be R minus 0, 1. Set of all real values of the function is defined for all real values of x except 0 and 1, right? I hope these questions are clear to everyone, guys. Let's move to another questions. Here for these questions also you have 30 seconds only. Okay, just try to solve these questions and write your answer in the chat box. Quickly. You have to use the same procedure, nothing else. Okay, what is the answer? Anyone got the answer? Okay, so let's discuss. Anyone got the answer? The solution is here, है ना? This function, it is in the form of f of x by g of x, right? So this function to be defined, g of x is not equal to 0. G of x must be not equal to 0. So in place of g of x, it is present x square minus 8x plus 12. And if we'll factorize x square minus 8x plus 12, we are getting x minus, very good, JNB Bhavnagar, very good, good. Your answer is absolutely correct. Okay. Okay. Chalo, let's discuss. So if we'll factorize the denominator, we are getting x minus 6 into x minus 2. So at the point x is equal to 6 and x is equal to 2, denominator becomes 0. If the denominator becomes 0, those points function will not be defined. That's why we need to exclude those 2 points from the set of all real numbers. Then the domain is r minus 2, 6. R minus the set contains the elements 2, 6. I hope this is clear. Very simple examples we have taken here. Let's see. What is the domain for this function? What is the domain for this function? Here the function is in the form of f of x is equal to under root of g of x plus under root of h of x, suppose. So this function to be defined, quickly solve this question and answer the answer here. This function to be defined, क्या होना चाहिए? G of x is greater than 0 and h of x is greater than equal to 0, greater than equal to 0. So there are two cases are arising here. One is x minus 2 is greater than equal to 0 and x minus, why I am taking and, because we need, this is f of x, this is one function, this is another function. So the domain of sum of two functions will be a intersection b. So here we are getting x minus 3 greater than equal to 0. Yes. So by solving these two inequalities, what we are getting, x is less than equal to 2 and x is less than equal to 3, right? X is less than equal to 2 and x is less than equal to 3. So take the intersection of these two intervals and what is the solution set you are getting, that is the domain of this function, right? Domain of this function. Let's see. Oh, sorry. So it is x is greater than equal to 2 and x is greater than equal to 3, right? So what is the solution set? Intersection of both the function, both the inequalities, that is x belongs to 2 to infinity and x belongs to 3 to infinity. The intersection portion is, if it is the set A, if it is the set B, so domain is A intersection B, right? A intersection B, that is 2 to infinity intersection 3 to infinity. So 3 to infinity. Is that clear to everyone? Yes. So 3 to infinity is your answer. Clear? चलो, बहुत ही अच्छा है. Who answered this question? JNB Gandhinagar, good. But x is greater than equal to 2 and x is greater than equal to 3. Right. Chalo, let's move to the next question. Here. Here for you one question. Find the domain of the following function. You have 1 minute for this question. Quickly solve this question. Quickly. जल्दी से solve कर लो. 1 upon log of 1 minus x to the base 10 plus under root of x plus 2. So how many cases are there here? You are getting how many cases are here? That is important. So first of all, what should you do? First of all, you should observe the question. So in the question, what is the function is given, and it is in the which form it is given. That is important, right? So you can see in the first function 1 upon log of 1 minus x to the base 10. Here in the denominator logarithm function is present, and in the second function under root of x plus 2 is given. So the second one is very simple. So this function to be defined, x plus 2 must be greater than equal to 0, right? So x plus 2 greater than equal to 0, that means x is greater than equal to minus 2. One solution you got for the second. And for this function to be defined, so what should you do? Log of 1 minus x to the base 10 must not be equal to 0. So when log of 1 minus x to the base 10 will be 0? Now when the argument becomes 1, when 1 minus x becomes 1, it becomes 0. Log of 1 is 0. We know, yes, just wait. Okay, 1 minus x, if 1 minus x becomes 1, then the function becomes 0. Log of 1 minus x will be 0. Log 1 is always 0. So this function to be defined, 1 minus x must not be equal to 1, right? So x must be not equal to 0. So another condition we got, x not equal to 0. Very good, JNB Gandhinagar. है ना? Another condition, another case we got here, that is x is not equal to 0. Acha, one more case is here. One more case is there. That is this log of 1 minus x to the base 10 to be defined. Okay, so this to be defined, the argument of the logarithm function must be greater than 0. That is 1 minus x must be greater than 0. Yes or no? है ना? That means by solving this inequality, what you are getting? X is less than 1. है ना? X is less than 1. So this is my first, this is second, and this is third. So just take intersection of all these three things, and what is the solution you will set, you will get, that is your answer, right? These are the conditions, these are the cases where the function will not be, the function will be defined, right? Let's see what is the solution. See, first we have taken this, x is not equal to 0, x is less than 1, and x is not equal to 1. Acha, x is not equal to 1 also, because 1 minus x is greater than 0. Already we have got this, na? We got this. 1 minus x is not equal to 0, greater than 0, right? We have taken this one. X is less than 1, x is not equal to 1, and x is greater than equal to minus 2. The same thing. These three things we are getting. That is, one is x is greater than equal to minus 2. This is minus 2. This is 0, 1, right? X is greater than equal to minus 2. This is x is greater than equal to minus 2. X is less than 1. X is less than 1. And x is not equal to 1. That is, x is not equal to 0 also. ठीक है? X is not equal to 0 also. Okay. So what is the solution set here we are getting? That is intersection portion. X is not equal to 1. 1 is excluded, and x is not equal to 0. 0 is also excluded, So what is the solution set intersection portion? That is -2 to 0. This is the intersection portion. X belongs to -2 to 0. Intersection, sorry, union. This is union. Why we are taking union? Because already we have taken the intersection. Now, what are the intersection portion we are getting? That is our answer. Union 0 to 1. 0 to 1. And 0 and 1 are both the n points are excluded, right? Because x not equal to 0 and x is not equal to 1 also, right? So x is not equal to 1. You understood this concept or not? X is not equal to 1 because here we got x is less than 1. X is less than 1. X is greater than equal to -2. X is not equal to 1. X is less than 1 means here we are getting x is less not equal to 1 also, right? Okay. Okay. So the answer is -2 to 0 union 0 to 1. I hope this is clear to everyone, guys. Clear? Clear, guys? So simply the rule is first understand the given question. Both the functions are given here. Two functions are given here. Second one is very simple. When the second function is defined, that is x is greater than equal to -2. And in the first one, what is present in the denominator? That is one logarithmic function. And this function, first function to be defined, the denominator must be not equal to 0. So when the denominator becomes 0, now when 1 minus x becomes 1, right? So this function to be defined, 1 minus x must not be equal to 1. This is second condition. And the third condition is this function to be defined, this function to be defined, the argument of the logarithmic function must be greater than 0, right? So this is the third condition. This is the third case. I hope this is clear to everyone, guys. Clear? Please write in the chat box if it is clear to all, guys. Remember, for logarithmic function, it's time actually. We need to go through the syllabus very fastly. Okay. Logarithmic function. Suppose the function is given as like this: y is equal to log of x to the base a, right? So this function to be defined, remember, this function to be defined, x must be greater than 0 and a is not equal to 1 and also a is greater than 0. Okay, that means a must be, one case is x is greater than 0, a is greater than 0 and a is not equal to 1, right? So this function to be defined, these three conditions must be satisfied. And how the graphs are? When a is lying between 0 and 1, the graph is decreasing function, right? Decreasing function. The domain is here. What? Domain is here 0 to infinity and range is R, right? Range is R. So when a is greater than 1, right? A is greater than 1. This is my first case. A is greater than 1. The graph is increasing like this. Same, the domain is same, range is same. Okay? These are all about your logarithmic functions. I hope all of you have covered all these things, right? So let's see. This is another question here. Find the range of this function y is equal to x minus 2 upon 2x plus 3. So how we can find the range of this function? Already I told you the procedure to the method to find the range of a function. right? How we can find the range of this function? That is important. So let's, yeah, how we can find the range of this function? So it is already written in the form of y is equal to x minus 2 upon 2x plus 3. Let's see the solution. See, first we'll try to, if it is here, if it is f of x, then you have to write the given function as y and try to convert the function, or try to write the function in terms of x. Try to write the function x is equal to some function of y, right? Like here y is equal to x minus 2 upon 2x plus 3. By cross multiply, we are getting 2xy plus 3y. When we will do the cross multiplication, we are getting this equation. So by simplifying, if we take this to this side, by simplifying, we are getting x is equal to minus of 3y plus 2 by 2y minus 1, right? So now so actually when we are finding the range, our aim is to find the values of y, right? So here first we need to the thing is, the important thing is we have to find the values of y, right? So already the first method is you need to write the function in terms of x is equal to some function of y, right? So from here, for which values of y x is defined, because x is your function here. Finally we are getting x is your function, that is x is equal to minus 3y minus of 3y plus 2 divided by 2y minus 1. So this is my function now. So this function, we need to find the values of y. Okay. So this function to be defined, this denominator 2y minus 1 must not be equal to 0. So that is y is not equal to 1 by 2. We got the answer. When you are getting the values of y, we got the answer, because we have to find the values of y. So y is this function x is to be defined. In case of range, this function x to be defined, y, this function x to be defined, here we need to find the values of y. Okay. So for all these values of y, that is r minus 1 by 2, r minus 1 by 2, for all these real values of y except 1 by 2, x is defined, that is range is r minus 1 by 2. So y का वैल्यू हम निकाल दिए, तो मुझे मिल गया भाई रेंज का सेट. Is that clear to everyone? Clear? If it is clear, let's we'll move to the next question. जल्दी से बताओ चैट बॉक्स में, क्लियर है? तो रेंज, in case of range, what should you do? The first thing is try to write the function as y is equal to that given function, and try to write x is equal to some function of, try to write that given function x is equal to function of y. Clear? Then for which values of y, find the values of y for which x is defined. From here, find all the values of y for which x is defined, right? Because x is here becomes now function. Clear everyone? So when you are getting the values of y, that is the set of range. Clear everyone? I hope this is clear to all. Please write in the chat box if it is clear to all. I'm waiting for you. And last question, I hope this is our last question. Find the range of y is equal to f of x on root of x minus 2, right? So this function to be defined, range निकालना है, ठीक है? So y is equal to on root of x minus 2. First we need to write y is equal to on root of x minus 2. Now square on both sides, y square is equal to x square, x minus 2, है ना? So we are getting y square is equal to x minus 2. Okay. So now we will write x is equal to function of y. So y square minus 2. Okay. X is equal to y square minus 2. So now my function is x, and the x is a function of y, x is a function of y. So this is a polynomial function. Y square minus 2 is a polynomial function. And the domain is here. For this function, the domain is R. So for all real values of y, for all real values of y, or when R belongs to y belongs to R, x is defined. So range set is the set of all values of y for which x is defined, right? So here the set of all values of y is R for which x is defined. So for all real number R, x, y, for all real number y, x is defined. So range is R. Clear? Range is R. I hope this is clear. Very simple question. Yeah. Sorry. What happened? What is the answer? It is given x is equal to y square plus 2. Oh, I'm sorry. It's it's bad. Y square is equal to, sorry, x is equal to y square plus 2. Sorry. Y square plus 2. If y square plus 2, we know y square is positive always. Sorry. Y square is positive always. If y square is positive, not negative. So if we'll add another positive number with y square, okay? If we'll add another positive number 2 with y square, it will give you again non-negative integers, that is starting from 0 to infinity. So the range is 0 to infinity, right? Y square is always positive. Clear? Clear everyone, guys? Okay. Let's move. This is the solution for you. Yeah. Now we'll see some special types of function. One is even and odd function, periodic function. Then we'll go through one onto function, into function, bijective functions. So let's start from even and odd function. So what is even and odd function? So the simple rule is, if f is a function and g is another function, if f is a function, when we can say it is even, when we can say it is odd, right? So when we can say it is odd, even, so even for a function to be even function, the property, the condition must be satisfying that by that function is f of minus x is equal to f of x. F of minus x is equal to f of x. So like if we take one example, f of x is equal to x cube, right? So in place of x, if we'll take minus x, right? F of minus x, so minus of x cube. So this will give you minus of x cube. Okay. So is it satisfying the first property? Is it satisfying the first property? No. This is satisfying, this is actually minus of f of x. So this is satisfying the second property. So when the second property is satisfying by one function, it is called odd function. It is called odd function. When the first property or first condition satisfying by some functions, then that function, those functions are called even functions. Like one example we can take here, f of x is equal to, simple example, x square. So in place of x, if we'll take minus x, this will give you minus x square, that is x square again. Then this is also f of x, right? So f of minus x is equal to f of x, right? So this x square is an even function, but this x cube is an odd function. I hope this is clear to everyone, guys. Clear? The definition of even function or odd functions. Clear, everyone? Sorry. Okay. If it is clear, let's move some example of even function and odd functions we have discussed. F of x is equal to x square is an even function or odd function? It is what? It is an even function, right? अरे अभी तो देखे थे ना, f of minus x, that is minus of f of x का square, that is x square, which is f of x. So it is an even function. Second function, for the second one, it is even or odd? It is even or odd? If we'll take, in place of x, if we'll take minus x, it will be giving you a to the power minus x plus a to the power minus of x. That is a to the power minus x plus a to the power x. Similarly, we are getting here f of x, right? So this is same as f of x. So f of minus x is equal to f of x we are getting, right? So then it is also even. This function is even function. Clear? Third function is even or odd? E to the power x sin x. So third function is, if we'll put in place of x minus x, right? E to the power minus x into sine of minus x, right? So e to the power minus x is e to the power minus x, and sine of minus of x is minus of sine of x. All of you know in trigonometry, sine of minus x is minus of sine x, right? So minus will be coming outside. This is equal to e minus of e to the power minus x sine x. So we are not getting any condition satisfying this, any of the previous two conditions satisfying by this function. So it is neither even nor odd. Array, here we are getting e to the power minus x, right? E to the power minus x we are getting, na? If we got e to the power x, then we can say it is odd function. But here we are getting e to the power minus x, na? So it is neither even nor odd. ठीक है? Clear everyone? It is even. It is neither case, huh? Neither even nor odd. Clear? Zenvi Gandhinagar, it is clear, right? Last question, f of x is equal to x upon x square minus 1. So in place of x, take minus x, f of minus x. So this will give you minus x upon minus of x square minus 1. So this is minus of x divided by x square minus 1. So this is minus of f of x, right? So here in this last case, we are getting f of minus x is equal to minus of f of x, right? So in the last question, we are getting an odd function. In the last question, we are getting an odd function. Okay. So these are the ways, this is the ways we can verify whether a function is even function or odd function. Clear everyone? Chalo, let's move. So these are some important notes for even and odd function. A function may neither be odd nor even. Already we have seen one example. Every even function is symmetric about the y-axis, and every odd functions is symmetric about the origin. That means here we are talking about the graph of even and odd functions. So always the graph of even and odd functions are following some specific, है ना, some specific क्या बोलते हैं उसको, specific way. Suppose even function, always remember even functions, the graph of even functions, note the graph of even functions are symmetric about y-axis, right? So example, same example we can take, y is equal to x square. Now simple example, the graph of y is equal to x square is like this. So we can see this graph y is equal to x square is symmetric about y-axis or not. If you'll fold it, if you'll fold this graph, or if you'll draw this figure on your paper, on your copy, and if you'll fold on y-axis, so one side of one right hand side of graph will be lying on the left hand side graph. So symmetric about y-axis, right? So always the graph of even functions are symmetric about y-axis. Similarly, odd functions, always the graph of odd functions are symmetric about origin, right? Symmetric about origin. Okay, so that is this. Okay, so this is example y of y is equal to x cube. You can see this is my origin. So this is my origin. If it is origin, okay, if you'll fold it, it is fold the graph, fold the paper by origin, then we'll get the graph will be symmetric. Both the side of the origins will be symmetric to each other, right? So then we can say always the graph of odd functions are symmetric about origin. Clear, everyone? If it is clear, let's move to next thing. What it is saying? Third thing is saying every function can be expressed as sum of an even function and an odd function, right? कोई भी फंक्शन को हम सम ऑफ एन इवन फंक्शन एंड ऑड फंक्शन में एक्सप्रेस कर सकते हैं. एवरी फंक्शन व्हिच हैज माइनस एक्स इन इट्स डोमेन, माइनस एक्स इन इट्स डोमेन, नथिंग एल्स है. हाँ, माइनस एक्स इन इट्स डोमेन व्हेनेवर एक्स इज इन इट्स डोमेन. छोड़ो. Like you can take example e to the power x, and this is the formula, this is the method to express any function, the sum of even and odd function. E to the power x, like e to the power x को हम sum of even function and odd function में express कर सकते हैं. कैसे? How? ना f of x, this is my f of x. F of x is equal to e to the power x plus e to the power minus x divided by 2 plus e to the power x minus e to the power minus x divided by 2. Clear? So this is f of x is equal to e to the power x plus e to the power minus x by 2 plus e to the power x minus e to the power minus x by 2. Check whether it is an even function or not. ये एक even function होगा and ये भी एक odd function होगा. So this is the way how we can express one function as the sum of an even function and odd function. Clear, everyone? Clear? Chalo. Let's move to some important concept here. Here we have given one table, है ना? When f of x is odd, g of x is odd, both the functions are even. One function is odd, one function is even. Okay, these four cases are given. So these are the results we are getting when you are subtracting, when you are adding, when we are multiplying, when we are dividing, right? So just my suggestion is to take a screenshot of this slide and it will be useful for your question solving or problem solving portions. Okay, like for one thing, one example we have taken, we'll take, suppose we'll take one odd function, f of x is equal to sin x, and sum of two odd functions I am taking. Suppose I am taking g of x is equal to x. Okay, so here a plus g, what we are getting? Sin x plus x, right? If you'll check this function, what you are getting? Sin of minus x plus minus of x. So minus of sin x minus x. So if we'll take minus as common, sin of x plus x. So this is minus of a plus g. So a plus g is a function which is odd. So sum of two odd function is odd. Like, so these are the ways we can prove also all these data is given in the table, right? I hope after this class you will try these all these data, all these proofs by your own, by taking example. Okay. Okay. So let's move. So this is a question for your homework. Good question. Okay. F of x is equal to sine of x to the power minus 7 into e to the power x to the power 5 signum of x to the power 9. So this is signum function. This is totally exponential function, and this is trigonometric functions. You need to verify whether this function is odd or even, right? So this is for your homework. In the next class, we'll discuss these things. Okay. And from the next class, we'll discuss some few special course functions like periodic functions, one functions, into functions, many-one functions, onto functions, bijective functions, and we'll start also composite functions and Riemann functions. Okay. So till then, bye bye. Take care, everyone. Thank you all. Thanks for your patience. Thanks for your time. Chalo, bye bye. Take care, everyone. It's time to end your class right now.